we're going to solve radical equations, and what that means is that we're going to find the value or values of x that make this equation true. And to solve radical equations, the first thing that we have to do is to isolate the radical. So I'm going to start by subtracting 4 from both sides, and that's going to give me square root of x minus 1 equals 1. And then after this, the second step is to elevate both sides of the equation to the power equal to the index of the radical. So this one is a square root, that means the index is a 2. So then I'm going to elevate both sides to the power of 2. And by doing so, I'm going to get rid of the radical, because the square root of x minus 1 times the square root of x minus 1 is going to be just x minus 1. And then 1 times 1 is just 1. So then we add 1 to both sides, and it's going to give me x equals 2. And every time that you solve equations, you want to go back and test the answer to make sure that it is indeed an answer. When we were working with rational equations, we learned about extraneous solutions. So those happen also with radical equations. That is the reason we always want to go back and test the answer. So what I'm doing right now is that I'm evaluating the equation for x equals 2. So that's going to give me 4 plus 2 minus 1 is 1. So it's going to be square root of 1. It's supposed to equal 5. The square root of 1 is 1, so that means that I have 4 plus 1 equals 5. 5 equals 5, so then that means this one is indeed a solution. But that is not always the case. Sometimes we have extraneous solutions. For instance, let's work with a square root of 2x plus 14 equals x plus 3. On this one, we do not have to isolate the radical because it's really nothing affecting it. It's been isolated already. So what we have to do is that we have to start by elevating both sides of the equation to the power equal to the index of the radical. So since it is a square root, that means that I am going to elevate both sides to the power of 2. And that is going to give me 2x plus 14 equals, and remember, this one is x plus 3 times x plus 3. You can either use FOIL or you can use the method we learned last semester, which means that it is the square root of the first term plus the product of these two terms times 2, which is 6x plus 9. And since we have a quadratic equation, we have to make everything equal to 0 because that is the way we solve quadratic equations. So we're going to subtract 2x and 14 from both sides. And we're going to do that so we can factor after that and find the value or values of x that will make this equation true. So that is x squared plus 4x minus 5 equals 0. So we're going to be looking for factors of negative 5. The sum is 4. So that is plus 5, negative 1 equals 0. We're going to use the zero product property, so that means that x equals negative 5, x equals 1. And we're going to go back and test those two answers into the original equation and see if both of them make the equation true. So I'm going to evaluate first for x equals negative 5. That's going to give me a square root of 2 times negative 5 plus 14. And this is supposed to equal negative 5 plus 3. 2 times negative 5 is negative 10 plus 14, that is 4. So I have the square root of 4. It's supposed to equal negative 5 plus 3 is negative 2. Well, the square root of 4 is 2, and 2 is not negative 2. Therefore, this one is not a solution. Now we're going to go ahead and test x equals 1. So that means that we will have square root of 2 times 1 plus 14 equals 1 plus 3. Well, 2 times 1 is 2 plus 14, 16. So it is the square root of 16 equals 4. Well, the square root of 16 is 4, and that equals 4. So that means this one is a solution. So this one wasn't, but the other one is. Let's try one more example. We're going to try 5 plus square root of x plus 1 equals 16. So the first step is that we have to isolate the variable. So to isolate the variable, we are going to subtract 5 from both sides. So that's going to give us a square root of x plus 1 equals 11. And then we're going to elevate both sides to the power of 2. So that is x plus 1 equals 121. We subtract 1 from both sides. So x equals 120. And again, you want to go back and test the answer. So you will have 120 plus 1 is 121. And the square root of 121 is 11. 11 plus 5 is 16. 16 equals 16. So this one is really an answer.